A remote forest in Siberia explodes with a force so immense it flattens millions of trees in seconds. There is no warning, no visible impact, no crater carved into the earth, just a silent, devastating release of energy that ripples across the landscape like an invisible shockwave. The ground trembles, the sky burns, and then nothing. When the dust settles, an entire region has been erased without a trace of what caused it. No fragments, no obvious origin, only destruction. It is as if something arrived, detonated in the air, and vanished completely. More than a century later, one question still dominates the investigation. What actually exploded over Earth that day? The event would later be known as the Tunguska explosion, one of the most powerful natural events in recorded history. Yet, unlike typical impacts, it left behind no definitive evidence of its source. No crater, no clear debris field, just anomalies. This absence of answers transforms the event into something deeper than a historical curiosity. It becomes a scientific puzzle that refuses to resolve, a mystery suspended between known physics and unexplained possibility. The location only deepens the mystery. Siberia in the early 20th century was one of the most isolated regions on Earth. Vast forests stretched endlessly, broken only by rivers and small scattered settlements. Human presence was minimal. There were no major cities, no infrastructure, no immediate way to investigate unusual phenomena. Whatever happened there occurred in near total isolation. This meant that the event would not be immediately studied, documented, or understood. For years, it existed only in fragments, stories, rumors, and scattered witness accounts from people who barely understood what they had seen. On the morning of June 30th, 1908, the region was calm. The sky was clear, the forest still. Local inhabitants went about their daily routines, unaware that they were moments away from witnessing something unprecedented. There were no signs of danger, no tremors, no atmospheric disturbances that could have hinted at what was coming. Then, without warning, the sky began to change. Something appeared above the horizon, bright, unnatural, and moving with impossible speed. Witnesses described it as a blazing object streaking across the sky, brighter than the sun itself. Some said it left a glowing trail. Others claimed it changed colors as it moved. To those who saw it, the object did not resemble anything familiar. It wasn't lightning. It wasn't a known celestial body. It was something else, something that didn't belong. The brightness was so intense that people shielded their eyes. For a brief moment, it felt as though a second sun had appeared in the sky, racing toward the earth. Then came the explosion, a flash of light so intense it scorched the air, followed by a wave of heat that could be felt miles away. For a split second, there was silence, an unnatural pause, before the shockwave arrived. When it did, it struck with overwhelming force. Windows shattered hundreds of kilometers away. The ground shook violently. Trees bent, snapped, and collapsed as if crushed by an invisible hand. The explosion did not come from the ground, but from above, radiating outward in all directions. For those close enough to experience it, the event felt like the end of the world. Witnesses were thrown to the ground by the blast. Some reported being lifted into the air. Others described a heat so intense it felt as though their skin was burning. The sky darkened, then glowed again. Many believed they were witnessing an apocalyptic event, something beyond natural explanation. The confusion was absolute. There was no immediate understanding, only fear and disbelief at the scale of what had just occurred. In the aftermath, the destruction became visible. An estimated 80 million trees had been flattened across an area of more than 2,000 square kilometers. Entire sections of forest were reduced to splintered remains. The force had not simply knocked trees over, it had stripped them, burned them, and scattered them across the landscape. The devastation was not localized, it extended outward in a vast circular pattern, suggesting an explosion of immense energy released above the ground. At the center of the destruction, something even more unusual was discovered. Trees were not randomly scattered, they were arranged in a radial pattern, all pointing away from a central point. This pattern indicated that the force had originated in the air, not from an impact with the ground. At the very center, some trees remained standing, but they were stripped of branches and bark, like charred skeletons. This strange combination of destruction and preservation challenged conventional explanations of impact events. Wildlife in the region did not escape the devastation. Animals were found burned, disoriented, or missing entirely. Some areas showed signs of intense heat exposure, while others suggested a powerful shock wave had passed through. The ecosystem had been violently disrupted. Yet even in this destruction, there were inconsistencies, areas that seemed less affected, patterns that did not fully align with known explosion models. The event was not behaving like a simple collision or explosion. Far beyond Siberia, the effects of the explosion were still being felt. In Europe and parts of Asia, nights became unusually bright for several days following the event. The sky glowed with an eerie light, allowing people to read newspapers outdoors at midnight. Scientists would later attribute this to particles injected into the upper atmosphere, scattering sunlight in unusual ways. But at the time, it added another layer of mystery. Something in Siberia had affected the entire planet atmosphere. Despite the scale of the event, the world did not immediately investigate. News traveled slowly and the remote location made access difficult. For years, Tunguska remained largely unexplored by the scientific community. It existed as a story more than a documented event, something strange that had happened in a distant, inaccessible place. This delay would later complicate efforts to understand the event, as crucial evidence may have been lost or altered over time. It wasn't until the 1920s that serious scientific attention was directed toward Tunguska. Russian scientist Leonid Kulik became one of the first to organize an expedition to the region. Driven by curiosity and determination, he sought to uncover the truth behind the explosion. But reaching Tunguska was not simple. The journey required navigating harsh terrain, extreme weather, and a lack of infrastructure. The investigation itself became an expedition into the unknown. When Kulik finally arrived, what he found defied expectations. There was no crater, no obvious impact site. Instead, there was a vast area of flattened forest, stretching as far as the eye could see. This immediately challenged the idea of a traditional meteorite impact. If something had struck the Earth with such force, where was the point of contact? The absence of a crater became one of the most defining and puzzling features of the Tunguska event. Further examination revealed more clues. The radial pattern of the fallen trees suggested that the explosion had occurred above the ground, not at the surface. This led to the concept of an airburst, where an object explodes in the atmosphere before reaching Earth. But even this explanation raised questions. What kind of object could release so much energy without leaving behind significant fragments? And why were there so few traces of its composition? Scientists began analyzing the soil, vegetation, and remaining debris. They found signs of intense heat, but not the kind typically associated with ground impacts. There were microscopic particles, unusual chemical signatures, and subtle anomalies in the environment. Yet none of these provided a definitive answer. Instead, they painted a picture of something complex, an event that did not fully align with existing models of meteorite impacts or explosions. The leading hypothesis became that of an asteroid entering Earth's atmosphere and exploding mid-air. As it descended, increasing pressure and heat would have caused it to fragment and detonate, releasing energy equivalent to hundreds of nuclear bombs. This would explain the lack of a crater and the widespread destruction. But even within this theory, uncertainties remained, particularly regarding the size, composition, and exact altitude of the explosion. An alternative hypothesis suggested that the object was not an asteroid, but a comet. Comets are composed largely of ice and dust, which could vaporize completely upon entering the atmosphere. This would account for the absence of solid fragments. It would also align with the atmospheric effects observed across Europe. However, comets typically behave differently when entering the atmosphere, raising further questions about whether this explanation fully fits the evidence. Other scientists proposed more unconventional explanations. Some suggested that a natural gas explosion from beneath the Earth's surface could have triggered the event. Others pointed to rare atmospheric phenomena that might produce similar effects. These theories attempted to reconcile the inconsistencies, but none gained universal acceptance. Each explanation solved some aspects of the mystery while introducing new contradictions. Beyond the scientific community, more speculative ideas began to emerge. Some claimed that Tunguska was the result of an extraterrestrial spacecraft exploding in the atmosphere. Others suggested secret weapons tests or unknown technologies. While these theories lacked credible evidence, they persist because of the unanswered questions surrounding the event. When a mystery remains unresolved, it naturally invites more imaginative interpretations. To understand the scale of Tunguska, comparisons are often made to nuclear explosions. The energy released is estimated to be hundreds of times greater than the atomic bomb dropped on Hiroshima. Yet, unlike a nuclear detonation, there was no radiation, no crater, and no clear source. This comparison highlights both the immense power of the event and the uniqueness of its characteristics. One of the most perplexing aspects remains the lack of identifiable fragments. Even in airburst scenarios, some debris is typically recovered. In Tunguska, only microscopic traces have been found, and even these are subject to interpretation. This absence continues to challenge researchers, forcing them to reconsider assumptions about how such events occur and what evidence they leave behind. In recent decades, advances in technology have allowed scientists to revisit Tunguska with new tools and methods. Satellite imagery, computer simulations, and improved geological analysis have provided deeper insights. These studies generally support the airburst hypothesis, but they also reveal complexities that are still not fully understood. The event remains a subject of ongoing research and debate. The implications of Tunguska extend beyond historical curiosity. It has become a key case study in planetary defense, the effort to detect and prevent potential impacts from near-Earth objects. Tunguska demonstrates that even relatively small cosmic bodies can cause massive destruction if they explode in the atmosphere. It serves as a warning of what could happen again. Modern monitoring systems now track thousands of asteroids and comets, identifying potential threats long before they approach Earth. However, Tunguska highlights a critical limitation. Not all objects are detected in time. Smaller bodies, like the one believed to have caused the explosion, can still enter the atmosphere without warning. This makes events like Tunguska not just historical anomalies, but ongoing risks. Imagine a similar explosion occurring over a major city today. The consequences would be catastrophic. Entire urban areas could be destroyed in seconds. Infrastructure would collapse, and the human toll would be immense. Tunguska happened in one of the most remote regions on Earth. If it had occurred elsewhere, history might remember it very differently. Despite decades of research, key questions remain unanswered. What exactly was the object? How large was it? At what altitude did it explode? Why are the physical remnants so scarce? These unresolved elements keep the Tunguska event at the edge of scientific understanding, where known physics meets unanswered questions. Each new study brings us closer to understanding, but never quite to a final answer. The evidence is fragmented, the interpretations varied. Tunguska resists simple explanations. It forces scientists to confront the limits of their knowledge and to remain open to possibilities that challenge existing models. In the end, Tunguska is more than an isolated event. It is a reminder that Earth exists in a dynamic and sometimes unpredictable cosmic environment. Events of immense power can occur without warning, shaped by forces beyond human control. And perhaps the most unsettling realization is this: the next Tunguska event is not a question of if, but when. The only uncertainty is where, and whether we will be ready when it happens.